Welcome to the video lecture series of data structure. Our today's topic is that how can we convert the general tree into binary tree. Hi, this is your instructor Janice Shah. So let's start with the outlines. Outlines are very common, that general tree conversion into binary tree. So let's directly start. That's what we exactly mean by general tree. Students, if you remember or if you can see this tree, it contains maximum child is 3. Okay. Now, if you remember the definition of binary tree, we can easily say that, sir, binary tree must contain maximum 2 child. Okay. Each and every node in a binary tree contains maximum 2 child. But right now, here the situation is that the root node A contains 3 child. Okay. Now, the node J contains again 3 child. So, in this hierarchy, if you can see, sir, is it a binary tree? No, it's not. So, what is it? It's general tree. That means normal tree. Because the constraint is that the binary tree must contains maximum 2 children. That's why this is not binary tree, it's a general tree. Okay, so let's start with the steps. Now, the steps to convert the binary general tree into binary tree. Now, the step number 1. In step number 1, students, you need to take the root node first. You need to take the root node first. Okay, then keep the left subchild or left child as it is. Okay, and then all the siblings of that left subchild, must be in a horizontal manner. So what you need to do is, step number 1 is just keep the root node as it is, then keep the leftmost child of root node as it is. Okay, and then do arrangement of siblings in a horizontal way in the right side of left subchild. Now step number 2 is, now arrange all the horizontal siblings on the right subtree of left child. Okay, now let's see how. So the first step is, okay, so this is the first step, that how can we convert the general tree into the binary tree. So this is our general tree, root node A, it contains 3 children, that is O, U and F. O has 2 different children, F and L, and then P and L, sorry. F contains 3 children, J, K, M. J contains again 3 children, R, Q, G. B and ZH are the child of P. Now, let's see how to convert this. So, very first step, make the root node as it is. Okay, so I'm just keeping the root node as it is. Then, take the leftmost node of root node and connect with it. So, here what I'm doing, I'm just keeping the left node highlighted with the black color. Okay, so it is like this. So root node is as it is, then keep the leftmost node on the left side. Okay, now let's see about what about the next. So next is, keep the siblings of node O arrangement in a right manner, or arranging the siblings of node O in a horizontal way. So here if you can see, the siblings of O are U and F. U and F. So just connect them on the right side in a horizontal way. Now we have just completed for the O. Now what is the next is, take O, left child of O is P. Okay, so just keep P as it is. Now what are the siblings of P? What are the siblings of P? P siblings is L. P sibling is L. So just keep it on the right side of P. So I'm just making it the right side in the horizontal way. Now very next step is, left child of P, that is Z. Left child of P, that is Z. Okay, is there any sibling for Z? Yes, it is. So just keep it on the right track, that is H. So up to now, if you can see, my all the left child are highlighted with the black color and the right child are highlighted with the little bit blue color. Fine. Now let's move further. How many nodes are left? Just find it out. Now U contains any child? No. So we'll go with the F. Okay. So F left child is J. Okay. Now how many siblings are there? Total 2 siblings are there, K and M. So put K and M on the right side of J in horizontal way. Now next, left child of J is R. Okay, so just keep R sibling again on the right side. Is there any sibling? Yes, we have Q and G. So just make Q and G on the right side. Now, is there any left child for K? No. Is there any right child for K? Yes. So what to do in such type of situation? When you have only one child with a node, then just consider it as a leftmost child. So just keep V on the left side of K. Fine. Now let's see the next scenario. So this is the step number 1, students. Now let's move forward to the next step number 2. So here it is step number 1 to step number 2. How can we go? So this is the step number 1. We have already seen this. Now let me convert this step number 1 in step number 2. What you need to do is you just need to move your siblings or your horizontal nodes a little bit on a right side. Okay, so in such a way your siblings or your horizontal nodes becomes right subtree of that particular node. Let's check it out how. See, the first we have A, the left node is O. Okay, now we have, if you can see, U and F both are there. U and F both are there. First take U. Okay, so just keep U on the right side of O. It goes like this. Okay, then F, again right side of U. It goes like this. Fine. So now, so the first line we have completed. Now let's see about the next. Next we have left side of O. So left side of O, that is P. Okay. So is there any right child? Yes. Keep L on the right subtree of P. Okay. Then students, we have left of P is Z. Okay. Is there any horizontal siblings are there? Yes, 2 siblings are there, or 1? Only 1 is there. That is H. So just keep H on the right side of Z. Next students, we have J. Okay. See, J is on the left side of F, so it must be positioned at same as like that. Okay. Do not forget to keep J on the left side of F. Okay. Just check out your first step number 1 and then do step number 2. Okay. So I'm just going to keep J on the left side of F. Now siblings for J are K and M. So you need to keep K and M on the right side of J. So there are 2 children K and M, must be on the right side of J. Now moving forward, we have left side of J, that is R. I'm just keeping R on the left side of J. Okay. Is there any sibling for R? Yes, that is Q. So make Q on the right side of R. Now, is there any node left? Check out J. Okay, J has V. Okay, R and G both are, sorry, Q and G both are the siblings of R. So I just forgot to keep it G. So I'm just placing over here. So after Q, G is there also. So G is on the right side of Q. Now, is there any node left? Yes, that is V. So just keep V on the left side of K. Now, check the step number 2 figure. Students, tell me, is there any node which contains more than 2 child? Just check it out. Is there any node that contains more than 2 child? No. Okay, wait for a minute. Is there any node that contains 0, 1 or 2 child? Yes, all of them. So that means there are no nodes more than 2. It means this tree is known as binary tree. So what you did? See, this is your question, which is general tree, and this is your answer. So you just converted your whole general tree into binary tree. Okay. Students, during the exams or during to writing in the notebook and paper, you have to make sure about the levels of the tree. Okay, each node must be at a perfect level. You do not make like this Z at bottom, L at top. Both are at the same level. Okay, Z and L both are at the same level. If you can see the figure, Z and L both are at the same level. So you have to keep it at as it is. Don't write like this that the line connected between P and Z is short and line connected between P and L is very long. So please don't do that. Okay. So that's it for today's lecture. Thank you so much, students.